up now. Here we go. Okay. Yeah, so if you want to write the title down, the vector triangle. So let me get the date right. Okay, vector triangle. Right, so we're going to continue talking a little bit about vectors. Okay, so now we're going to have a look at how we can add vectors together. So vectors can be added together by using what's called a vector triangle. Or at least that's one way you can add them together. So imagine you have two vectors, vector A and vector B. To add these vectors together, which is called the resultant vector, so you might want to write that down. That's what you call the vector when you add two together. The answer is called the resultant vector. We'll call it OR. You can find it from the diagram below. So the way it works is you have your A, then you take the tail of B and put it at the head of A. So A and B are back to back. The resultant is from the tail of A to the head of B. So this is the resultant vector here. So this is the vector triangle. This is how you can add two vectors together. So for example, just very quickly, if I had here, here is vector A, and then let's say here is vector B. If I want to add them together, I put the tail of B at the head of A, and then from tail to head, that's A plus B, that vector there. So that's the vector triangle. Straightforward, I think. So to add two vectors, you must put the tail of one vector at the head of the other. Oh yeah, so interestingly, it doesn't matter which way around you did it. So for example, if you were to put the tail of A at the head of B, so if we were to put A at the tail of A at the head of B and make B plus A, you can see it's the same vector. So that's useful to know. Now, a vector, do you need to draw that triangle?
No, I understand it.
Yeah, you sure? Yeah. Okay. A vector can be multiplied by a scalar, by a number. When a vector is multiplied by a number, for example, if you multiply it by 2, it gets twice as big. So if you multiply by 2, as an example, it will double in length. Likewise, if you were to multiply by a half, then it would be halved in length. And if you multiply a vector by minus 1, it would flip around 180. So, for example, here, let's say this is my vector, I'll call it A. So this here in red will be the vector a half A. And this here will be the vector 3/4 A. And this here will be the vector 2A. And then this one here, I'll do it in green, this one here will be minus A. And this one here, for example, will be minus a half A. So the scalar just changes. When you multiply by a scalar, you just change the length of the vector. Although if you multiply by a negative scalar, like minus 1 or minus 2, it flips the vector around. Yeah.
What if it multiplies a vector as well?
We won't do that in physics. But that is something you would do in further maths, and something you would do in physics next year. We'll do something kind of like it in maths next semester, but it's a tiny bit too advanced for the physics class. But you can do it. You can multiply a vector by a vector. It is possible. Okay. Do you need to write anything down from this? Are you sure?
Yeah.
Okay. Right, so of course we can add, subtract, multiply and divide scalars, like always, as normal. We can multiply or divide a vector by a scalar, so you can multiply a vector by 2 or multiply it by a half. That's like dividing by 2. We can add or subtract vectors. Now just to be clear, I showed you how to add, but you can also use that to subtract. So for example, if this is A and this is B, well then this here is minus B. So then this here A and this here minus B. This here will be A plus minus B. In other words, A minus B. So you can subtract vectors as well. Oops. Yeah, okay, that's all to say about that. We cannot multiply two vectors. Well, we can kind of, but that's more something we do in maths class. So for now, we'll just say we can't multiply two vectors together. And we definitely cannot divide a vector by a vector. We can never do that, maths, physics, or otherwise. So we can never divide a vector by a vector. This is impossible. So that's what we, so just to be clear, that's what we can do, and this is what we can't do. So just really, for now, two things we can't really do. Okay, so let's have a look at some questions. Can you write this one down, please? We'll have a look at this now. It does. Actually, that's part of the question. Yeah, yeah. So that isn't a mistake. They are different units. Yeah. So, oops. Oh, sorry, I can go to. You have this written down, yeah?
No, only A.
Okay, well, we'll do A first.
Okay.
Alright. So, let me see. We have here A is 5 kilometers to the east, and B is 5 kilometers per hour to the north. So in red here, for example, this would be A, and the blue vector, that would be B.
You don't have to connect it at first, right?
Yeah, you don't have to touch them at all. You could put them, I could put the B over here, which I'll do. Actually, okay. There's B. Right, that is A. So B now, what do you think? Can these vectors be added?
Yes, because they are both vectors.
And the right answer is no. But why am I saying no?
Because they are different units.
Yeah, so it doesn't matter that they're vectors. What's more important is that they have the same units. So in fact here we say no, because the units of A, or the dimension of A, does not equal the units of B, which means it's not possible to add them. Yeah. Right. So next one now. Actually, let me just make sure I'm recording. Yeah. Consider TB, where T is a scalar, 2 hours. What's the dimension of TB? Okay. Write that one down, and let's see what answer you get. What do you think?
The dimension is b squared, right?
B squared.
And the unit will be 10 kilometers.
No, not this. Let's have a look at it. Okay. So we want the dimension of TB. That's the dimension of T, the dimension of B. Now just remember what T is here. It's 2 hours, isn't it? And B here, what did we say it was? It was like 5 kilometers per hour, kilometers per hour north, or whatever. So you can see here that the dimension of T is time, and the dimension for B is length per time. So these cancel, so it's just length. So then the unit would be, well, yeah, actually kilometers, because that's what we're using here, or meters, whatever. Yeah. So it's length for TB. Okay, let's have a look at what's next. Okay, so draw TB. Okay, so what's going to happen with TB?
It's just going to be a line to the north, which is 10 kilometers.
That's it. It's 10. Yeah. Is it 10 or is it? It's 10 because it was 5 then. Yeah. So this now is 10 kilometers long. So that's TB.
Can I copy Siri?
Oh yeah, sorry. Yeah, you need to get this, of course. Do we have 1 or 2 classes now?
This is our second class.
Yeah, I mean, like this morning, do we have a single or a double class? Can't remember.
It's a double.
It is a double. Okay, yeah.
Okay.
Yeah. Next now, what is the resultant of A plus TB? Okay, so that's TB, which is 10 kilometers long, and then A is a vector. What do we say? 5 kilometers to east, was it? Yeah. So that was A. So head to tail, tail to head. What is it? Tail to head. So if I just put the A here, so that's A over here now.
But do you want us to draw TB?
Oh, we're on to the next one, the resultant of A and TB. So there's A, and then here is TB. Yeah, that's it. So there you go, that's A plus TB. I should have actually asked if they could be added together, but they can, because A is in length and TB, we just said, is in length as well. In fact, the length we know exactly. This length here is 5 kilometers, and this length here is 10 kilometers. And this one is to the north, and this one here is to the east. Okay. So, the last part, yeah? So I want to see the question, sorry, yeah.
It represents a resultant vector.
Yeah. Now, can you interpret what it is?
It resembles the shortest route from
I wouldn't even say it's as difficult as that. What you could think of it as, here is A by itself, and this is in kilometers, so it's a position, so I'll just write POS. And here is B, and B is so that's A, here's B. B is in kilometers per hour, so it's actually like a velocity, kilometers per hour.
But they don't want B anymore, they want A.
Oh, I know, I'm building up to it, yeah. So then TB, what's the unit for TB? Kilometers, so it's a position. So it's this position vector plus this position vector. So it's a bit like somebody who started at position A, and then they walked north at B, which is 5 kilometers per hour, and they walked for 2 hours, so they ended up here. So this is their new position. So in other words, what does it represent? It represents an object at A walking, well, it doesn't have to be walking, moving with velocity, moving with, oh no, that's a bad sentence. Or is the final displacement for an object that starts at A and moves with velocity B for t time. Okay, do you want to write that down then? Although that was a tricky question, I wasn't really expecting anyone to get that. Yep. Okay. Next now. So I have another question here. So you can just write the information down at the start here. A man walks 5 steps north, 5 steps west, 1 step east, and 1 step south. Okay, you got the information? Yeah. Right, so the first question is, what was his speed for the journey? What's the speed?
Uh,
So let me just.
Distance over time.
That's it. Yeah.
So you just need to add everything together, divided by the time it took for him to get there.
That's it. No, do I give you the time? 9 seconds.
Yeah.
So let's draw what happens here. So he goes 1, 2, 3, 4, 5 north. 1, 2, 3, 4.
What is the distance for each step?
It doesn't matter because it's like the distance unit is steps.
Okay.
What am I doing? 5 steps west. Is that 5? No, that's 4. 5 steps west. 1 step east. So he goes back a step. And then finally 1 step south. Now it might actually be helpful if you did this on graph paper. So you can see that he ends up here. This is his final position. So the number of steps he took.
5.
Yeah, it will be 5 plus 5 plus 1 plus 1. So he took 12 steps.
So it's 12 divided by 9.
That's it. So the first one, his speed, is the distance divided by time. So that's 12 steps divided by 9 seconds. So what's that? 1.33, isn't it?
Like if it's in fractions?
Yeah, there's a button called SD on it here.
Oh, okay. Yeah,
1.33 steps per second. Okay, let's have a look at the next part. Oh, I did it. Yeah.
This is just one that is maybe 5 centimeters north and another one.
Yeah. The only thing I didn't really draw is the displacement vectors. So, for example, at the beginning he's here, and then after he walks 5 steps north he's here. Then after he walks 5 steps west he's here. Then 1 step east he's here, and then the final displacement vector is he's here. So that's the displacement vectors. Displacement points to where he is.
Oh, from the beginning.
From the beginning.
Okay.
Or about from the origin.
Okay.
Yeah. So those little black vectors are like his motion, his velocity.
Okay. So
Yeah.
we're supposed to draw the red ones.
Oh yeah. Well, I kind of did in the black ones. His velocities, that's B. And C are his displacement vectors.
Oh, okay. So velocity vector is the red one.
Yeah.
Okay.
So those little black vectors, they would be, I don't know,
The displacement.
what would they be? They'd be about do we say 1.33 steps a second or something like that? Because remember, velocity has to have it's a speed as well, so it has to have a length and a time. So those little black step vectors, they would be 1 step, 1.33 steps per.
No, 1 step takes
One
1.33 seconds. Right?
No, we said it backwards. 1.33 steps per second.
Oh yeah, right. Yeah.
Yeah. So those little black lines are 1 step. So the time, I think, will be then 0.75 seconds. Anyways, we're thinking too much about this for a first lesson. I just need the drawing.
It's like always if they ask a velocity vector, it's always from the origin. Right?
Displacement, you usually draw from the origin, but the velocity you usually draw wherever it's at. So for example, like here, if this was moving, you would draw the velocity vector on the object that's moving, whereas the displacement one is from the origin and it points to it as it moves.
Oh, okay. So
Yeah.
the displacement vector is the red one, and the velocity vector is the black one, right?
The velocity is the black one, displacement is the red one.
Yeah.
Yeah. Okay, can we go to the next part? That's okay.
So just like this, right? For B.
For B, what do you mean? Let's see.
It's just that, right?
Displacement ones.
The velocity vectors.
The velocity ones.
Yeah.
Let me go back to it for you. The black ones.
But it doesn't have to be arranged back, I mean like head to tail, right? Because they just want the velocity.
No, I guess what I'm doing is it's like you're looking at its velocity at each step. So it's almost like I'm trying to show you its speed at every moment of its journey. But you wouldn't have to do it like that.
Yeah, but it's like, I understand that. But for this question, will this answer suffice?
For velocity one? No, they shouldn't really be different lengths because his velocity, he's walking at the same rate. So this is more like his displacement, I guess, for the yeah, they wouldn't quite be velocities. They'd have to each be the same length because I don't think he's getting faster or slower. This is more like if you multiply his velocity by the time in that direction.
Okay.
So like
So it's all the same length.
I think that would be a bit better to do, yeah.
Okay.
Yeah. Okay. Right. We continue? Yeah. Okay. Let me just close this for 1 second. Alright, where were we now? Around about. Right, so the next part is what is the magnitude and direction of his final displacement vector? So if you look here, this one, I'll try and draw it in blue. This is his final displacement. So you can see it's 1, 2, 3, 4 to the west and 1, 2, 3, 4 to the north. So this is exactly 45 degrees, which means it's exactly northwest. The length, I actually tell you in the question, if this is 4 and this is 4, then this is 5.65. I say it in the... That's it, yeah. That's it, yeah. So the answer would be, for part D, 5.65 steps northwest. Yeah. Question?
Answer for C is like that, right?
Yeah, C is all the different ones from the origin, yeah.
Can I see the question?
Yeah, yeah.
Can I answer 5.65 steps due northwest?
Yeah, yeah. Yeah. So the last part, that's a typo. It should say, what was his average velocity? So, do you remember velocity?
Yeah.
It was displacement or position over time. So that would be 5.65 steps northwest divided by, what was the time? 9 seconds. So you get 0.628, so 0.629 steps per second northwest. Okay. Yeah. Notice, interesting, I think, if you look at his average velocity, it's 0.629 steps per second northwest. And then if you look at his average speed, it's 1.33 steps per second. They're different. So you just really need to be careful about speed and velocity.
So if they ask a question about velocity, the answer, we have to add the direction.
Yeah, yeah.
Always.
Yes, yeah, absolutely. And in the exam, I remember at least one question that was a little like this, where you had to be careful because one part of the question asked for speed and the other part asked for velocity, and there are two different answers. In fact, you can see they're quite different. Like, the speed is nearly twice the average velocity's magnitude. Okay, so we have to be really careful when dealing with vectors, speed and velocity then. Next now. So A and B, when we add them together, we can say the addition is commutative. That's actually something I said earlier. That is A plus B equals B plus A. So I think it's good to at least write that word down. Commutative means that A plus B equals B plus A. Some questions for you to try. I think what we'll do is we'll just take a 2 or 3 minute break if I don't know if you need to get a coffee or whatever, and then I guess you will have enough time to finish these now. So if you get all of these finished, then there's no homework for you to do for the next class. Did you get chemistry homework? Oh, okay. Oh yeah, that's right, just the labs. So you had nothing to do yesterday evening then. Did you have a look at Google?
No, I didn't.
That's okay. You didn't need to because there's no trouble. You have your first maths class today? You didn't have maths yesterday, is that right?
Yeah, there's maths class with the kids.
Okay. So if you want to take a minute or two, or do you just want to try the questions? Do you need to take a break, or you're...
I mean, I'll try it, but you can get a coffee.
I'll get just a coffee.